Hey guys, welcome back to the another problem of SQL. So in this video we will be discussing the problem which is asked by Agoda, Gojek and Grab in their assessment for data science and data analytics roles. And I will be discussing with this problem which is related to counting the number of passengers in the bus. So let's get on to it. And as we can see here, we have two tables, table name buses and table name passengers. And there is a result format of how our count of passengers result should look like. So it says it should have bus ID and the passengers on board. So let's explore a bit further, like what isn't in the buses table and the passengers table. We see the buses has a bus ID, the origin where the bus is starting and the destination. The time is the departure time of the bus, and this is for a single day. If you see the passengers table, it has a passenger ID, and similar to bus table, it also has origin, which is the starting point of the passenger, and the destination. The time here is actually the arrival time of the passengers. If we see here, these are the set of conditions which is provided as part of assessment. So first is Pax will board the earliest possible bus. If we see second, Pax can board the bus which departs at the same time which Pax arrives. So that kind of hints us to equality condition. The third condition we see here is all Pax who are at station at 23:59 time and don't board any of the 23:59 buses will leave the platform without boarding any bus. That's fine. If we see the last condition, no two buses with the same origin and destination depart at the same time. Now, in this problem, we have to actually count the passengers on board in each bus. However, the few assumptions which I can see here is this problem is only for a day, so we won't try to overcomplicate it by thinking from the angle that passenger can board the next day's bus or the next to next day's bus, because this is only day's data. And also, this assumption makes us clear that no two buses with the same origin and destination depart at the same time. So, I will give you some time to think about the problem. Usually, try to build a mental model of the problem first, write a query, and explore the tables using select star statements for both buses and passengers to see if there are any data issues or if what you're assuming are correct, and then try to solve the problem. You can pause the video here if you want, and once you have done with the mental model, also try to code the problem out, and if you are able to code the problem out, I think then you can tally with the solution which I will be discussing next. Okay, going to the mental model, we know that we have to somehow join these two tables base if we want to compute the number of passengers on the board. So a passengers whose origin is Paris won't go in the bus whose origin is Warsaw. So one thing is very clear to us that if we join these two tables, then the origin of the bus and the origin of the passenger should match, and the same goes for destination. We can actually utilize one more condition, which is the condition number 2, where it says Pax can board the bus which departs at the same time, and condition number 1, which is Pax will board the earliest bus possible. So which gives us to a condition that the arrival time of the passenger, which is this one, should be less than equal to the departure time of the bus. The condition is less than equal to, and only in those cases the passenger will be able to board the bus. Also, one if we do a left join, this will give us all the buses which are arriving later at a later time, when the which are departing at a later time when after the passenger arrives. So if we see here, bus 2 is arriving at departing at 10, and the arrival time of the pax is 9 o'clock. And bus 3 is also departing at 12, which is greater than the arrival time. But pax 1 can only board will board the earliest possible buses. So in this case, bus number 2. So this hints us to an idea where that we have to use some kind of ranking, and only take the first bus out of this. So there is a function in SQL, rank function, which does exactly that. We will actually rank and partition by pax ID, and we will order by the departure time of the bus to create something called as rank value. If we go there and so this will be rank 1, this will be rank 2. Once we have got the rank, we will actually only filter where the rank is 1. So this will give us all the records where the passenger which is boarding which bus, and there will be 1-to-1 relationship. Now if you see the result, it also contains the passengers on board where the value is 0. That means buses went empty. The logic here discussed so far will give us the buses which have at least one passenger. And also there is an assumption that we can already sense that the bus's capacity is infinite, right? So in order to account for buses which are going empty, we actually will need to join the result back to the buses table which we initially got. And this will give us basically all the buses, irrespective whether the passenger is, if it is going empty or if it is going filled. And finally we have to sort it by the bus ID column. Now for those of you who weren't able to think about this mental model, once now you have already known it, I would nudge you to complete the query on your own, and maybe then look at the solution, but I will be jumping to the solution directly. So as discussed, we will join these two tables. Here we can see we are joining buses B with the passengers P table, and we are doing a left join here. And the condition as discussed is the origin of both table and the destination of the both table should match. And what we are saying here is that the bus's departure time should be greater than the passenger's arrival time. The rank function which we discussed also, we are including it here. So we will be doing rank over partition by passenger ID and order by bus departure time to get the first earliest possible bus for each of the passengers. So in order to include do the ranking for each of the passengers, we need to partition by passenger ID, because if we don't do it, it will not give rank 1 for other passenger ID. Let's say pax 2, it will start with 3, but for different passenger ID, rank should again start from value 1. So that's why we are doing partition by here. Then based on the base table, we will be creating a filled bus alias, and we will be filtering for where the rank value is 1, and we will be grouping by bus IDs and counting the passengers. So this is what exactly it does. Then we come to zero packs buses. So zero packs passenger buses are the buses which are not filled, and all the important conditions here are highlighted in green. So we from the buses B table, we actually exclude the bus IDs which are part of the filled bus table. So once we have done this, we call it zero packs bus table, and our final answer is nothing but a union of filled bus and zero packs buses table, and we will be ordering the result by the ID column in both final result. So this is the correct query. I submitted it and got it 100% correct. However, I couldn't solve it in a real time editor because it was part of the test. So I hope it helps, and I will be posting the query in the comment section. Feel free to drop any questions you have or any doubts regarding this problem.